Hi, this is Gejo. This is part of the series of tough DILR questions. Now this is the second video on that, and in this particular video I'm going to look at a CAT 2006 DILR question. This is on Erdos number. This set is a challenging set in the sense that you take time in every single process of solving DILR. That process that I discussed in the last video is a process known as ROOT, which is you read, you understand, you deduce, and you execute. The total time is the time that you take to read the question, time that you take to understand what the set wants you to do, time that you take to deduce whatever information from the information, make deductions, inferences that you draw, and then eventually execute and answer those questions. And in this particular set, you take time to read, you take time to understand, you probably take time to deduce, and in some cases you take time to execute. But this particular set is important in the sense that it gives you a good sense in terms of how to go about solving DILR. Now this is a set. What I've done is I have given a link to this set on the description box. Please download it, solve it yourself, and see how it went. Okay, so now this has got three parts. So there is part one, which is here, which is trying to give us a foundation. So this is basically introduction as to how this particular number called Erdos number is calculated. So that's where the first part is, and then there is a setup in terms of the specific question, and these are the rules, or the in the sense rules of the game, rules of the game that are based on this particular setup. So in this case, the step of reading and understanding, both of them is going to take a bit of time, and therefore you have to kind of be careful even to understand how to calculate this Erdos number, right? So let's go with the first process in terms of reading and understanding what this is. It says mathematicians are assigned a number called Erdos number. So there is a number called Erdos number, named after famous mathematician Paul Erdos. Only Paul Erdos himself has Erdos number 0. So we have this gentleman called Erdos, and his Erdos number is 0. And any mathematician who has written a research paper with Erdos has an Erdos number of 1. So any mathematician who has written research paper, let's call some of let's for example, let's say ABC. Let's say 3 mathematicians who wrote paper with Erdos, and it says that they will have a value which is 1. Their Erdos number is equal to 1. Therefore it's kind of suggesting how far away you are from Erdos. So this is like one chain away, one chain away, one chain away. That's kind of what they represent the number, Erdos number is. And then it says, supposing a mathematician X has co-authored with several other mathematicians. So let's try and understand what that means. So if let's say there is X which is co-authored with several other mathematicians, let's think of 3 mathematicians there. From among the mathematician Y, let's take X, Y, and Z. So let's say there is a co-authoring that happened between X, Y, and Z. From among the mathematician Y has the smallest Erdos number. So we have the information about Erdos number of Y. Let the number be equal to Y. So let's say Y has an Erdos number of Y. Then X has an Erdos number Y plus 1. That's how that change. If Y has an Erdos number of Y, then X will have the Erdos number Y plus 1. And mind you, this is the smallest. And then hence any mathematician with no co-authorship chain connected to Erdos has a Erdos number of infinity. So it's like how close you are to Erdos. One way to look at and understand this whole thing is, let's say that there is a D, F there, let's say G, H co-authored, and then G co-authored a paper with I and J. Let's say that happened, and I co-authored a paper with, let's say, K, something like that. So what is essentially happening is that now among these two, the lowest is 1. So now D will have a value which is 1 plus 1, which is 2. Same the case with here. This will get a value 2. This is get value 2. This get the value 2. Now if you look at these 3 of them, the lowest is 2. So then this will get the value 3, and this will get the value 3. And between these two, the lowest is 3. So K will get a value which is equal to 4. That's what Erdos number is eventually. So you just need to understand this as like that. What does this 2 essentially mean? There were 2 chain away from this gentleman Erdos. What does 4 mean? 1, 2, 3, 4. 4 away from Erdos. What does this 3 mean? 1, 2, 3. 3 away from Erdos. And what does this 2 mean? 2 away from Erdos. So how far you are away from Erdos is what all that you're doing. So once you kind of do it is a simple addition that happens. All you have to look at is take the lowest number, add 1. That will be the new Erdos number. So whoever is around there will have an Erdos number, which is take the lowest one and add 1 to that. So once you've understood this particular part, let's go ahead and look at the setup. Now in the setup it says that in a 7-day long mini conference. So already I'm thinking that there is day 1, day 2, day 3, day 4, day 5, day 6, day 7. We now have to think of a board to write in the piece of information. So there are 7 days. Conference by Paul Erdos. A close group of 8 mathematicians, call them A, B, C, D, E, F, G and H. So we have this another set of parameters. We have A, B, C, D, E, F, G and H. Okay, so you're almost thinking like a 7 by 8 matrix already. Has discussed some research, but at the beginning of the conference, A was the only participant who had infinite Erdos number. So A had an infinite number which is infinite, and nobody had Erdos number less than that of F. Nobody has Erdos number less than that of F. So F is the lowest. So what is now going to happen is whoever is going to work with F will have, let's say F has got Erdos number which is X. Whoever is going to work with F will have an Erdos number X plus 1. So this is the hero of our story apparently is equal to F. Now one of the things that you realize when you try and read this information or the set of rules of the game, you understand a very peculiar thing. So the first talks about what happened on the 3rd day. The second talks about at the end of 3rd day. So this is one, 3rd day is important. And next it says something that happens on the 5th day. Something that happened on the 5th day, and goes on to say that no other paper was written during the conference. So what you realize is this so day 7, day 6, day 4, day 2, even day 1, so to speak, are inconsequential, no discussion. What we have to look at is just what happened in day 3 and day 5. And therefore the board that we could go with. So if you are thinking of drawing a board to go with, that board will look like, okay, we have a so let's say there are the 8 of them, 1, 2, 3, 4, 5, 6, 7 and 8 of them, and this is what happened in the beginning, and then something happened in the day 3 and day 5. Day 3, 1, 2, 3, 4, 5, 6, 7, 8 of them. Day 5 we have 1, 2, 3, 4, 5, 6, 7, 8 of them, and certain information is given about F and A. F is the lowest. Let's take that value to be X, X to be equal to the lowest, and A has something, a value which is infinite. So that's the kind of board that we can work with and figure out probably writing this name depending upon what things happen. So we have some information that is given that in the first case F co-authored with A and C. So A is in play, then we know that C is in play. So we'll probably need to put C somewhere. Then he talks about Erdos number of B, D, E, G and H remain unchanged. Okay. Then the next case talks about E co-authored with F. So now we have E is in play. So these are FACE, FACE. Those are the 4 ones in play. The rest of them we don't know what is happening in this case. So it's probably a good idea to look at the question, and I think it's a must that you should look at question eventually whatever you're doing to answer those questions. If you look at each of the question, it talks about how many participants in the conference did not change Erdos number. Okay, this is good. So the good news is that we have got some specific value. The bad news, of course, is that there is something that says cannot be determined. So there could be multiple possibilities, not necessary, but it is possible if the answer is that. And the next question says, how many person, the person having the largest Erdos number at the end of the conference must have the Erdos number what? Now this is a good one because there's a specific value. So whoever is having the largest Erdos number will have what particular value. The next says how many participants had the same Erdos number at the beginning of the conference. So now you have at the beginning of the conference, what the story is, we have something which is cannot be determined. We have 2, 3, 4 and 5. So therefore one of the things that is important is what happened at the beginning is kind of important, and what happened at the end is also kind of important for this question. And what is the change that happened during the conference. That's what that is. And the next question talks about Erdos number of C at the end of conference and E at the beginning of the conference. So we are also interested in what specifically happened to these two guys, C and E. Also, the good news about that particular question is the fact that we have specific value. So this seems to be a case where you'll get quite a few values. There could be a possibility that something cannot be determined. We don't know for sure, but we need to look at what happened in the beginning and the change. Like I already told you, in this case, the thing that matters is what happened in 3 and 5. Okay, so let's go ahead and solve this. Let's create the board. That's a very important step in terms of creating the board. Let's go ahead and create the board. So we have 1, 2, 3, 4, 5, 6, 7, and 8. And let's say this is what is happening in the beginning. And let's say at the end of day 3, 1, 2, 3, 4, 5, 6, 7, and 8. And at the end of day 5, something is happening. 1, 2, 3, 4, 5, 6, 7, and 8. And whatever happens. It's basically very clearly says here that no other paper was written during the conference. Something happened on the 5th day. Something happened on the 3rd day. Nothing else happens. So this is my end, anyways. This is also, I can think of my end, because whatever happened in day 5 is what happened in day 7 at all. And whatever the change that has happened from the beginning to the end is the change happened because of whatever happened in day 3, and probably whatever happened day 5 as well. Okay, this is at the end of day 5. That's actually the end of everything. Okay, let's start plugging in the values that we know for sure. We know that F and A. F is the lowest. So since in that chain F is the lowest, anyone who get attached to F is going to get a value which is 1 more than the value of F. So let's take that value to be X. And A started with the value of infinity, which is what has been mentioned here. Okay, A was only one with infinite value. What you realize is that F is not going to change at all throughout the course of the 5 days, because F is the lowest. So for the F value to change, he has to do a research paper with someone else who has got a lower value than F, which is impossible. The F value is not going to change. Let's look at what happened on day 3. On the 3rd day of the conference, F co-authored a paper jointly with A and C. F co-authored jointly with A and C. So we have C in place, and since F co-authored with A and C, and F is the smallest, and this will now change to X plus 1 and X plus 1. Okay, that's what that happened. This reduced the average Erdos number of the group of 8 mathematicians to 3. The average has gone to 3. So which means we need to look at a value. We need something that is a total value there. Okay, it would probably make sense to think over the total here. If the average is equal to 3, there are 8 of them, the total will go to 24. Okay, so let me pick another color. The total in this case is 24, right? And then says that the Erdos number of B, D, E, G and H remain unchanged. So B, D, E, G, H, so those values remain unchanged. We don't know what that is. We don't know what is the value of B, what is the value of D. Therefore I'm not going to write it on top here, just going to leave it there. They remain unchanged. It says further, no co-authorship among any 3 members would have reduced the average of Erdos number of the group as low as 3. So, okay, let's understand what that means. With that, no other co-authorship among any 3 members. So you have A, B, C, D, E, F, G and H. So what happened in this case, F is co-authored with A as well as C. No other combination is going to reduce it as low to C, which is, first of all, that would essentially mean that A already started with infinity. But it also tells us that in the beginning C must have pretty high value. Okay, so if, for example, if C, let's take a specific case, if C's value is 7 and D's value would have been 8, and then C's value now reduced to, let's assume the case where F's value is 2. Let's take a specific case. Let's just take the specific case, which let's assume that C was 7, F was 2, and the 7 went to 3. That's our X plus 1. That's a reduction that happened, which is -4. And if somebody else had a value which is 8, for example, and that combination would have reduced the value to 3 again, because 2 plus 1 equal to 3. No, it says that no other co-authorship among any 3 members would have reduced the average that low. This should have been -5. So this is not possible, which means among at least the rest of them, D, E, G, H, B, C would be pretty high. The value of C would be high. That's what that means, right? A is anyway infinity. If you take any other combination, it's not going to work at all. So this is the lowest. This has got a highest reduction. So C's value is pretty high. That's what that means. If you want to make the deduction, so making the deduction from here would have would require a little bit of trouble. But then if you think about it, you'll understand that C has got a definitely pretty high value. So at least we know that this particular value of C is greater than value of B till H. Okay, B C D till H. So that's what that means. Okay, let's move on and look at what happened at the end of third day. At the end of third day, 5 members of this group had identical Erdos number, while other 3 had Erdos number distinct from each other. 5 had identical. 2 already we are seeing is identical. Now the other 3 are distinct, which means A and C cannot be a part of other 3. So that would definitely mean that whatever this 1, 2, 3, 4, 5 must have a value x plus 1. Correct. So that's what that means. So that would mean that this would take the value x plus 1. So we have we need 5. 1, 2, 3, 4 and 5. Another 3 there is 1 is x. So we have, let's call a variable y and variable z. Great. Now in this case what you realize that probably an equation can work here. We'll figure that out later. Okay, we're already running with the variables, so we have probably some equation that can work with 3 variables. Let's see what happens at the end of day 5 and then figure out what happens. Okay, on the 5th day, E co-authored a paper with F. So E co-authored, so we have E co-authored paper with F, and the average of the group of Erdos, reduce the average number of the group by 5. The reduction of the average of group with 0.5. Now there are 8 of them. 0.5 times 8 is 4. The reduction of the total will be equal to 4, which means the total would have gone down to 20. Right. So that's the reduction. Reduction will be -4. And it also says that the Erdos number of the remaining 6 were unchanged with the writing of this paper. Nobody else has changed. The only value that changed is E. Now E can either take the value x plus 1 or 1 of y or z. So let's pick y or z, doesn't matter. Okay, which one is it? Let's take E is x plus 1 or y. Now if E is x plus 1 and is co-authoring with x, nothing's going to happen, right? So x plus 1, which is the lower? X is the lowest. E is going to remain at x plus 1. That's what it means, no? So for example, if somebody has got a dose value of 3 and someone is co-authoring the paper, the lowest among them is 2. This person will go value which is 2 plus 1 equal to 3. Nothing is going to change. So E cannot be x plus 1. That would mean that E has to be either y or z. So let's assume that E in this case is y. Okay, and the remaining everything is exactly the same: x plus 1, x plus 1, x plus 1, x plus 1, and then therefore there is this z here. Okay, now please understand that E is co-authoring with x with f. Sorry, that value is x. Therefore, the new value of E is going to be x plus 1. Right. Now we can understand what has happened here. This is -4. All of these are exactly the same. All of these are exactly the same. -4, which means this value should be x plus 5. X plus 5 minus x plus 1 will have 4 as a reduction. So that would then mean that we can go and say that, look, this is a case that this value is going to be x plus 5. Okay, and we can probably would understand what would have happened in the beginning. So initially the co-authoring happened with FAC, and then the second case E co-authored with F. So nobody else has changed the story. Okay, so in the beginning what has happened, we have no idea what would have probably happened to the value of C here. We don't know, but we know for the rest of them they have not co-authored any paper from beginning to day 3, so nothing changes. So this also nothing changes. Here also nothing changes. E only co-authored in the second. That's where the change happened, -4. But otherwise E would have remained the same. We have Z, so that's something that we can find out. And in this case, whatever is the value should be actually greater than these guys. And I think that we have this now we have this equation which is simply has got 2 variables, either work with this or work with that. So let's figure out certain values here. Great. So let's look at what the story is. So we have 1, 2, 3. So we have 1, 2, 3, 4, 5, 6, 7x. So we have this 7x plus z should be equal to 20 minus 1, 2, 3, 4, 5, 6. So 20 minus 6 equal to 14. And this is and please do understand x and z has to take a natural number value. X obviously cannot take the value 0 because the only person who can have the value 0 is Mr. Erdos. And this is now a simple equation that you can solve. We can write z equal to 14 minus 7 times x, and z therefore equal to, if we take 2 of 7 common, 2 minus x. So what are the values that x can take? X obviously cannot take the value 0. X also cannot take the value 2. If x takes the value 2, this particular thing, if x is going to take the value 2, 2 minus x will become 0, z will become Erdos. Erdos is not part of the story, only Erdos is 0. The only value that x can take therefore is equal to 1. That's a simple story. X will take the value as equal to 1, x equals to 1. If x equal to 1, z will be equal to 7. That's it. So I think that if I think that would get us to say that all these value would therefore make sense. So this value would be equal to 7, and we can go ahead and write the value of x to be equal to 1 and fill this up. 6 and 2. 6 and 2, which will then definitely mean that our value of c here, please do, we have already gathered at the beginning that c has to have a value which is greater than all of these guys, so which means c has to have a value which is greater than 7. That's the only thing that we know here. So probably we can write it, say that c must have a value which is greater than 7. Right. So that's our story, and then this is here the deduction in this case is also challenging to kind of do try and making sense of what is given here, putting the right kind of board to then answer this question. Alright, so now let's look at each of these questions. We have this thing that's there. So how many participants in the conference did not change their Erdos number during the conference? Who did not change? F did not change. 2, 3, 4, 5 of them did not change. Answer to this question, ladies and gentlemen, is 5. The person having the largest Erdos number at the end of the conference, the largest Erdos number at the end of the conference is 7. That value is equal to 7. Good. Next question. How many participants had the same Erdos number at the beginning of the conference? At the same Erdos number at the beginning of conference? 1, 2, 3. 3 of them had the same Erdos number at the beginning of the conference. So therefore we can say that that value would be equal to 3. The Erdos number of C at the end of the conference. The Erdos number of C at the end of conference, it's 2. Erdos number of E at the beginning of conference. Erdos number E at beginning of conference would be equal to 6. Yes, so executing this is fine. So once you get the table in place, everything is done. So in this particular question, ladies and gentlemen, you understand this 4 process: read, understand, deduce, and execute. Here, reading and understanding would have taken time. So reading itself would have taken time, understanding would have taken time. This probably would be approximately a 4-minute process. But then deduction is to look at the right kind of board to go out with, and this probably could go anywhere between 6 minutes, maybe 6-7 minutes, but execution will happen pretty quickly. This can be done in about a minute and a half. So overall, I'm thinking that this particular set would have taken about 10 minutes approximately. Obviously you can solve faster than that as well, but roughly I believe that it will be a test with about 10 minutes or 12 minutes kind of a set. But I hope you understood the process, breaking down the process of reading, understanding, deduction, and execution. So yeah, thank you. I'll add more videos on some more tough DILR sets. Till then, see you. We'll be right back.